then select the app Google Collaboratory. And here, after opening the file, you need to make a copy for yourself, okay? Or you can make a new file and then just copy the scripts one by one. So here we will make a new file. So that is a new notebook, file new notebook. And then hmm, let's name this data visualization. The file extension is IPYNB, or short for I Python notebook. So this is actually this ID is a notebook where you can run Python scripts. So the first thing that we do here is write the libraries that we need. So we will be needing Seaborn. Let us copy our previous code. We will be importing this libraries. We will need these libraries. Okay. So we copied and paste it here. So what we see here are the Seaborn and Pandas, Seaborn and the Pandas library. So these are the two of the libraries that are wrappers around Matplotlib, and both are very useful to create plots quickly. However, even if these are used, a good knowledge of Matplotlib helps to have more control over the final plot. We also have the ggplot library that is modeled after the equally named R package by Hadley Wickham. It is based on the grammar of graphics, a term coined by Leland Wilkinson to define a system of plotting theory and nomenclature. Learning ggplot effectively means becoming familiar with its philosophy and technical knowledge of plotting. So a few other packages are used for specialized plots. We have Seaborn for heat maps, Gmaps, and Cartography for map visualizations. We also have NumPy, that is a library for the Python programming language, adding support for large multidimensional arrays and matrices. If you're dealing with arrays, you will be using NumPy in Python, along with a large collection of high-level mathematical functions to operate on these arrays. NumPy are used for working with arrays. Then we also have Pandas. It is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. That is most widely used for data science, data analysis, and machine learning tasks. And we also have the scikit-learn, that is the most useful library for machine learning in Python. The sklearn library contains a lot of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction. So next, we have to run this, but we also imported the DMDA, which is the library where we will get all our data all our data sets. So we need to install this first because some of this or all of this except VMDA are already installed in Google Colab except for VMDA. So we need to install this first. So let's add a code above um, and it's for the first. It's to be the first to be run. So we need to install VMDA. We have the code script pip install to install a library. So we need VMDA. And so we can run each cell by clicking this. It's like the play button. And then we run the importing of the libraries and packages. So done, successful. And next is we'll add another code set. But first, let us show you the data sets that we will use. We will be using the Boston housing data, which contain information on census tracts in Boston. Um, let's see the our data set. We will be using the Boston housing CSV. You can also look at the actual data set used from the NBA. So we can create a copy of the data set or you can open the data set using this code. PDF equals VMDA. That's the library that we installed um, a while ago. VMDA, and then we use the method load data to get the data from Boston Housing.csv. So here we use we just opening accessing the Boston Housing CSV and then save it, store that into the variable called housing df. So this is like a variable that will hold all the data from Boston Housing.csv. And here we have the df here we put df here in our variable to indicate that this variable is will hold data frame. So a data frame is it's a two-dimensional labeled data structure with columns of potentially different types. And we can think of it like a spreadsheet or table, okay, or um, a series of objects, and it is generally the most common used timeless object. So if you're holding if your variable holds a table, then that's a data frame. So we can use that variable and can play it, or before playing we can print the variable to see what's the data housing DF is holding. So we have a print method to print the data of housing DF. So here we can see um, there are 506 rows and 14 columns. So we cannot see here now um, the in between data. You only see the row 0 for the first 5 rows and the last 5 rows. But I will also, if you want to see, you really want to see the whole CSV file. This the CSV file where you can open it using Excel, I will also send the data set. So here we have um, 506 rows. This is the last row, and the index is 505 because the index of the first row starts at 0. And then there are 12 columns: cream, ZN, Indus, Chas, Nox, RM, age, Dis, Rad, Tax, P, ratio, LStat, MEDB, and CAT, MEDB. Okay, CAT space MEDB. So the cream column is the crime rate, and then ZN is the percentage of residential land zoned for lots over 25,000 feet square. Then we have induce is the person it's the percentage it's the percentage of land occupied by non-retail business. The SAS is whether or does the truck bound Charles River, and the value is 1 if the truck is bound river and 0 otherwise. The NOx is the nitric oxide concentration. That's parts per 10 million. And then the RM is the average number of rooms per dwelling. With the age is the percentage of owner-occupied units built prior to 1940 is the age of the units. And the BIS is the weighted distances to 5 Boston employment centers. The RAD is the index of accessibility to radial highways. And the tax is the full value property tax rate per $10,000. And then we have the PP ratio, or the pupil to teacher ratio by town. The LStat is the percentage of lower status of the population. Then MEDV is the median value of owner-occupied homes in $1,000. It's the median value. And then the CAP MEDV is it's a category whether or if it is if the median value of the owner occupied homes in tract is above $30,000. So if it is above $30,000, then the value is 1, and if not, the value is 0. So this Boston housing dataset is an example dataset, and it is derived from information collected by the U.S. Census Services concerning housing in the area of Boston, Massachusetts. So this data has 506 rows and uh, 14 columns. Then we also have the second data set that we will be using is the Amtrak, which is a or second data set is the ridership on Amtrak trains. So Amtrak is a U.S. railway company. Routinely collects data on ridership. So let's take a look at the Amtrak data set. So let's add a new code cell, and then let's name our new data frame as Amtrak DF. Then we use DNBA that load data, and then the file name of Amtrak is amtrak.csv. Then let's print the data frame and run. So Amtrak has 159 rows and two columns. So the columns are the month and the ridership. So let's now take a look at the basic charts that we can plot using Python. We have the basic charts, the bar charts, and line graphs and scatter plots. So these are the three most basic, effective basic plots. These are the bar charts, line graphs, and scatter plots. So we can create this plots using pandas, and the plots most commonly used in the current business world and in both data exploration and presentation. So basic charts support data exploration by displaying one or two columns of data, variables at a time. This is useful in the early stages of getting familiar with the data structure, the amount of the amount and the types of variables, the volume and type of missing values. So we have here an example of line chart. So let's make a line chart here in our notebook.
Pwede ra mga link akong ipasa sa
So
inyo ng mga
line
katong sa
charts, by the way,
extension
are
community
used for
extension activities.
time series
Ay nana
analysis.
pigi sa inyo.
So um,
Ano mo
what we
mag-picture sa
want to
inyo sa
show
library
here
mo.
is
Wala ako.
time series. We will be using the Amtrak dataset because its data is applicable for time series analysis. As you can see, you have um, it has the month, okay, which is needed for time series analysis. So the best graph for time series is the line chart. Okay, line graphs. These are used for line charts or line graphs. These are used primarily for showing time series. To do this, we have to copy the code that was given, and then let's create a new code cell. So this is our script for creating the line graph. But before that, we have to change, okay, or we have to make we have to do some formatting to our data set. So here we make a date column here from our DF, from our Amtrak DF, we create a date column. So as you can still remember, the Amtrak have month and ridership. Now we create a date column. And then that's from the date to we to do this to add this new column, we have to use the panda library, which is in the shortcut of pd, and then we use the method to underscore datetime and include in the parameter the Amtrak df.month, which is the month column, and we format it with D and Y. So you will see that the date column will get its data from the month column. Okay, and then we have Another variable here, we have the ridership TS. Now its postfix is TS. That means this is a time series data. This data is used for time series. And to make a time series, we add the series method from the pandas from the pandas library. So pd dot series, then we add the values of the ridership column, this column, okay, that's our value with all the values. We add that to the time series, and then the index will be the date. The date column, which is the one we just created here. Okay. And then we run this, and we can also print to see the results, to see the data of the ridership PS. You can see what's the difference. The ridership PS, that's the result of our new script. And what's the difference of the untracked PF? This is the original dataset. And then we modify it, and its new name is ridership PS. We modify it, we add a date, and we make a time series having the ridership values, and the index is the date column. So we run this, and we can see now that we have only two columns. One is the date, and then it's value, the ridership value. The previous one have two columns, month and ridership. Now, in a series, we only have one column. We only have one column. It's the ridership value, and the index are the date. To identify them uniquely, we have the date. For example, the ridership value for the date 2003 December 1. So we can identify that by the index date, and the value is 2140. That's 677. In the original dataset, the indices are from 0 to 158. These are automatically assigned by Python. Okay? Each rows will have its own index. In a series, we can make our own indices. And in a time series, it is usually the date that is being set as the index. So we can now make our line graph. So let's add another code cell here, and then we use the time series variable, the ridership, the recent data that we created, and then we have a y-lim of 1,300 and 2,300. So that basically the data on our y-axis. Okay. Then we have legend equals false, and the fig size is 5 and 3. So fig size is used to determine the size of a figure object. So the first value there is the width, and the second is the height. Okay. So 5 is the width, and 3 is the 3 is the height. Then we have the X label is the year. This is the X-axis label. So let's run this. You can see here the white rim is from 1,300 to 2,300. How do you determine this? This is from your data set. Okay. You can see here the the minimum value. You can set any value, which is the minimum, and the maximum. You can explore what's the minimum and the maximum, then you have to set them here. 1,300 and 2,300. So those are the ridership in thousands. And then it automatically um, adjusted to shows that the first value here is 1,400 and the last is 2,200. It automatically adjusts. And then we have here the X label. The X label is the year, as you can see here the in your X-axis, and the label in the Y-axis is ridership in thousands. Ridership in thousands. And then you have the type layout method and then show the plot. So you have this plot. Then we add another code. You can make there's another way to do this, which is the use of Matplotlib. So in Matplotlib, we have this code. plt.plot, okay, which we use the Matplotlib. So we have that plot, and then it has different syntax now from this previous one. So we have the ridership PS index, use the index and the ridership PS. And the X label is here, and the Y label is ridership and PS. So it's more lesser code. This is equivalent to this, but this is the use of the different library, the Matplotlib. Okay. So let's run this and you will see the same result. Next is we will create the bar charts. So bar charts are useful for comparing a single statistic. Example, if you compare the average, the count, the percentage across groups. So the height of the bar or length in a horizontal display represents the value of the statistic, and the different bars correspond to different groups. So let's show here our next example. But first, let's make the scatter plot. So we will make the scatter plot here, and we will use the Boston housing, the first latest. And here we have the housing data. Then we load the data from Boston housing. We already loaded the Boston housing, so we can delete this. And then um, based on the Boston housing, we will rename the column there because there is that space MEDV. We will change this column If you can observe a while ago, here in our Boston house in Philippines, the cat that MEDV is not formatted or not well formatted, it is placed on the last year, the last column, the cat dot space MEDV. We will rename this to cat underscore MEDV. To rename, you have this code um, that rename using the name of the variable housing df. Then we add that rename. Then the columns that we want to rename is the cat medv. And then the second value is the new name. This is the original and this is the new name. So housing df.plot, this is how you make a scatter plot. We use the plot method and then for the dot scatter. Then we have in the scatter plot you want to see the L stat in the x axis and the med v in the y axis. So instead na ang or the x the L stat again is the percentage of lower status of the population in in Boston. And then the med V is the median value of owner occupied homes in 1,000s or in thousands in the value of 1,000s. So the median value of owner occupied homes. And then we show the product here. So let's run this. Now you can see the scatter plot of the two variables, the L stat in our x-axis and the med v in our y-axis. So this scatter plot is an important plot in the prediction task. So again, the med v is on the y-axis and L stat on the x-axis. So because both variables in a basic scatter plot must be numerical, okay, remember that the variables in the scatter plot should be numerical. They are in the form of numbers and it cannot be used to display the relation between cat med v. So the purpose of the scatter plot is that it will help us study the association of the two numerical
Wadto na ta,
values.
Mambeng?
What are
Dili pa.
their
Ato pa kag
relationship?
bangko.
As we can see here, we used to show the relationship or the association of med v and the L stat. So we show that their association in terms of information overlap as well as identifying clusters of observations. So as you can see that there are more relationship around here in this area. Okay, in that those that are the status or the L stat having 10 in the value of 10, we, we can observe those that are those who have a percentage of lower status. Their percentage is around 5, 10, and 15. Commonly, there are more um, 5% or 10% or 15% lower status of population, they are also more associated to the the median value of owner occupied homes. They are more associated the to the MEDV values of 10 and 20. Next is we can show another scatter plot with the use of the Matplotlib. So with the use of Matplotlib, you can add more aesthetic to your plots. So the code for Matplotlib is um, we will copy here. This is the code for Matplotlib, and here we can set the color and the face color for drawing an open circle. So this is another way to make or create a scatter plot with the use of Matplotlib. So here it's the same with the previous one, but it's more clearer now. And the darker circles are you can see that this have more relationships. Those values with LSTAT and MEDV have more association with the two variables. The darker circles are clearer here using Matplotlib as compared with the previous scatter plot. So next is we have to create a bar graph. So here we group the chas variable and we get the mean and we get the negative using the bar graph, and the fig size is 5, width and height is 3. The y label is average med v, and then we show the plot. So we have the chas. The chas is the variable having the value 0 and 1, and the average med v are from 0 to 25. So again, the chas variable is the values 1 and 0. 1 means if the track is bound Charles River, and 0 if not. If it's bound with if it's bound Charles River. Okay, if the housing, okay, in Boston. This refers to the housing. So you have here, there's more. And the average MEDV, again, the MEDV is the median value of owner occupied homes in $1,000. So that means um, this is 5,000, 10,000, 15,000, 20,000, and $25,000. That's their median value of their homes. Okay, so that means those who are bound to that means in one, those who are bound in Charles River are more have more median values, no, of their homes, and those that are not bound to Charles River have an average of median value less than 25,000. And then we can use another Matplotlib. Using the Matplotlib, we have You can change its color and add more aesthetic here. We have data per plot, and then this is the syntax for Matplotlib. We use the group by, chast, and then the mean of medb. So we get the mean and we plot. We set the x-axis 0 and 1 for task. Then the color is C5 and C1, and the X label is chas and the Y label is average medley. So this is the result using the matplotlib. So these plots are shows the bar chart for the categorical variable cat medley. So it shows the separate bars. No, these bars are used to denote homes in Boston that are near the Charles River. Those are with value 1, just 1, and then 0 are those that are not. So we compare the two categories of trust. And the chart with the numerical output medv uses the average medv on the y-axis. So in the bar graph, you take note that the x-axis on a bar chart must be used only for categorical variables, meaning the variable has categories such as, in this example, we have category 0 and category 1. 0 means the home is not near the Charles River, and 1 means that the homes are near the Charles River. So they are in a category. So categorical variables. And this is because the order of bars in a bar chart should be interchangeable. So this plot shows us that the tracks bordering the Charles are much more likely to have median values above 25K or 30K. So next we have the box plot and the histogram. So these are two plots that display the entire distribution of a numerical variable. So we will show you the box plot and the histogram. Uh, this will show us the median and the standard deviation of a variable. So we will examine their distribution. So bar charts can only use a single application, and the box plots and histograms display the entire distribution of a numerical variable. So box plots are also effective for comparing subgroups by generating side-by-side box plots. But before that, let's show you how to do what's the script to create box plot and um, the histogram. Let's add a new code cell. Then we have here, we use the AX, um, the one we created in last, we created here for grouping the chat.